Good afternoon, everyone. Now we'll start the second session. I welcome our today's guest, Dr. Ganesh sir, on behalf of AGPIT Institute of Technology. It gives me immense pleasure to introduce our today's guest. Ganesh sir is Assistant Professor in Mathematics Department from Savitribai Phule University. He has pursued PhD from IIT Bombay in 2011. He has specialization in various areas like commutative algebra, Hilbert functions on grid models. He has published many papers. Recently, he has published paper on spectra of a zero divisor, graphs of finite reduced rings in 2023. Even he has worked in research projects like Hilbert polynomials associated to derived functors of torsion functors. During his academics, he has received awards and fellowships like NBHM scholarship during MSc, CSIR fellowship during PhD, and IMS prize at the annual conference of the IMS held at IIT Kharagpur for best research paper. He was a speaker for many conferences. He has organized many conferences, workshop and lecture series. I would like to request our today's speaker, Dr. Ganesh sir, to start his session on specific writing for research papers. I hand over the mic to you, sir. You can start the session. Thank you.
Thank you, madam. So before we begin, let me thank the authorities of the college, A.G. Patil Institute of Technology, for inviting me here to speak. I'd like to check a few things before we begin. So is my presentation visible to you?
Yes, sir, it is visible.
Okay, so I've shared my entire screen. If you, in case you want me to share a single screen, I can do that. But I think it's fine. So if you want me to share a single screen, I can do that. But so in between, I basically would like, so in the middle of the talk, I'd like to give a small demo of this package, plagiarism check package, which is this is the one that we use at our institute, the Turnitin, and so that's the reason I've shared my entire screen. Anyways, so the title of my talk is scientific writing for research papers. So as I understand this FDP, Faculty Development Program, the participants are mostly engineers. They are so to say teachers in various engineering colleges. I come from mathematics background. I do not have, I've taught to engineering students at the College of Engineering, Pune for about a year. But beyond that, I don't have much experience. I mean, with the way, I mean, particularly since the topic of this FDP is research paper writing and IP rights. So, you know, given that the audience is engineering people, but nevertheless, I think the general principles of scientific writing, okay, for research papers, they won't vary much. There will be some specific things that probably you would expect me to speak, but I'm not expert on those matters. But anyway, so there are some general principles I would like to convey to you, and I don't think they will vary that much. So there are some general underlying principles for scientific writing. So whether it is in sciences or engineering, I don't think they will remain invariant. So all right. So what is scientific writing? I don't want to give you a very academic kind of definition, but broadly speaking, scientific writing refers to writing that is aimed at communicating scientific findings or outcomes to a wider audience. So this wider audience could be people in particular working in particular area of research, or they could be general public, or administrators, for example. Okay, so and so you want to write your findings. You've done some research, let's say, and you want to communicate that to a broader audience. Okay, and so how do you do this? So one must approach this question of scientific writing scientifically, in the sense that what are some general principles that one must keep in mind, in order to write better. Okay, so what is more likely to get accepted, for example, right? So so first question is, what are the characteristics of scientific writing or good scientific writing? Are there any rules? Is there any rule book of scientific writing? Okay. What is the relation between ethics and scientific writing? Okay. How does one develop good writing skills? Okay. You want to write a research paper. So one of the basic questions that people often ask is, if you send it to a good journal, then how likely the paper is going to get accepted in the journal. So and how, if you write well, so what are your chances? And if you don't write well, uh, what happens? How the editors or reviewers, for example, how like, say, for instance, if you make some very basic grammatical mistakes, let's say, then but you have some very good scientific content, okay, to present. You solved some very some remarkable problem. You've developed some machine or some algorithm, and you make some very basic, when you write about it, you make some very basic grammatical mistakes, let's say. Okay, there could be various problems, but let's just ask this question, that if you make some very basic grammatical mistakes, but your scientific content is great. um, so what are your what chances do you stand? I mean, what are your chances of your paper getting accepted in a good journal? Okay, right? So these are the kinds of questions we want to answer. Then so are there any tools to improve scientific writing? Okay, some packages maybe to help you write better. Okay, so these are the kinds of questions which come to our mind, or which people often ask, and we will try to answer some of these questions. And you also, once you are done writing your research, uh, there are many more questions, like, say, for instance, um, so which journal do you send your paper to, right? So these questions also we will briefly discuss in this talk. Okay. Now, scientific writing is typically published through books, journals, conference proceedings. Now, conference proceedings are more common in, I think, engineering, whereas in sciences, these are not. I mean, there are conference proceedings, but they are not considered that prestigious. Like in engineering, I think some of the conference proceedings are considered very prestigious. So there are these differences, of course. In sciences, for example, a journal publication is valued more. But again, there are journals, there are good journals, there are not so good journals. Okay, so on and so forth. So there are these differences, of course. But yeah, so scientific writing is typically, you have these broad categories like books, journal, conference proceedings, scientific or technical reports. Many times even governments, they are interested in publishing some scientific reports. Like, say, for example, a report that focuses on pollution levels, it can be considered as a technical or a scientific report. Okay, then there are expository and review articles. Um, Expository and review articles, which are so expository articles, for example, are aimed at exposing people to some particular area of research or some particular topic that needs attention. Review articles, you all know, they focus on reviews of in a particular area, for example, or on a particular problem. So and there are many other things where scientific writing can typically get published. Now, let me first let me begin with something about history of scientific writing. And the reason why I want to discuss this, spend some time on history of scientific writing, is because I think there are some remarkable examples in ancient India and also in ancient Europe, and these examples are worth following. Okay, and it is remarkable that in uh, times as old as, say, uh, uh, 1500, I mean 300 BC, let's say, people wrote so well. Okay, so that is something I want to point out, and particularly I want to point out, there are a few texts I want to point out. So in ancient, in India, for example, we had a rich intellectual tradition, and people often wrote about their scientific findings in various languages, but particularly you will find these writings in either Sanskrit or Pali, and there are some other regional languages also. And when it comes to mathematics and astronomy, Indians made great strides. So, for instance, you have Buddhayana, Brahmagupta, Bhaskaracharya, Madhvacharya. So, Madhvacharya belonged to Kerala School of Mathematics, and he developed calculus, ideas of calculus, much before, I think, maybe 200 years before Newton. And this has come to light very recently. Okay, and the whole school, I mean, there is a generation of astronomers or mathematicians, and they wrote about their findings. And their finding, I mean, the writings are also so precise, and um, you know they are examples worth following. Then there is Hemchandra, Aryabhatta. Okay, so there are these mathematicians and astronomers. Uh, in physics and chemistry, you have Nagarjuna, who was a great Buddhist scholar and a philosopher, scientist, and you have Kanath, who lived in 200 BC, 600 BC to somewhere between 600 BC to 200 BC, and he proposed uh, some you will find the origin of atomic theory, for example, in the ideas proposed by Kanath. So Nagarjuna, you will find some ideas about chemistry. Then in linguistic, okay, you have Panini, and this is one example I want to kind of highlight. So Panini, most of you probably know that Panini was Sanskrit grammarian, and he wrote this fantastic book known by the name Ashtadhyayi, which I think consists of about 4,000 sutras, maybe 3,000 or 4,000 sutras, and he kind of defines language, the grammar of language. He defines this language in about 4,000 sutras, very terse sutras, and it is very methodological, or if one wants to put it in modern terms, it is algorithmic. So probably if there are computer science people here, they would be able to understand this. You can literally make codes out of these sutras. They're very precise. They tell you how inflections are to be applied, how words are to be derived, how sentences are to be formed. So you can form literally infinitely many sentences out of this very, very basic kind of finite set of rules, and it is so precise. Okay, if you look at it, it's very terse. The sentences are very short, but they carry a lot of meaning. So this is one example which is, I think, really remarkable from the scientific writing point of view. Okay, and then there were other grammarians like Patanjali and Hemchandra. Um, so in short, I mean, some of these people, so even Brahmagupta, for example, in this, mathematics and astronomy. So he was a very good writer. He solved what is called Bell's equation much before Euler solved it in Europe. And his solution is so, I mean, the way he writes it, it's so precise and so beautiful. Okay, so these are some of the Indian examples, uh, and you have this great history of scientific writing. Then in Europe too, you find a lot of scientific activity, particularly after 17th, 16th century. And but even before 16th century or 15th century, you had Euclid. Okay, so this he was in uh, 300 BC, and he wrote this remarkable book called Elements, which discusses foundations of geometry. Okay, and he introduces what is called axiomatic approach to geometry, and which is so modern in perspective actually. So you can imagine, as far as back as in 300 2300 years ago, he wrote this book, fantastic book, and even by modern standards, it would be called a remarkable sort of book. um, then you have Johannes Kepler. You all know Kepler's laws of motion. He proposed these Kepler's laws of motion in his book Astronomia Nova. Then you have Isaac Newton, who wrote this very fantastic book, The Mathematical Principles of Natural Philosophy. So some of these basic principles of laws of motion, or even calculus, ideas of derivative and integration, find these ideas proposed in this book. And so Newton, so it is actually a good exercise to actually download this. You will easily find it on internet, and so download this book, some of these books, and see how how these mathematicians, scientists, they wrote how. So look at the, so for instance, Newton's book on mathematical principles of natural philosophy. It is so precise. Okay, the language, look at, there are so many aspects to be observed. So it's so precise, and uh, you know uh, uh, and the content, of course, I mean, the greatness about these books is that they have some great content. Okay, then you have Carl Friedrich Gauss. He was a mathematician and a physicist. Then you have Euler, a physicist and a mathematician. He wrote this book, Mechanica, and also the Foundations of Differential Calculus. I mean, there are many other books, but probably for the engineering audience, this mechanic book on Mechanica would be more interesting. Uh, so, all right. I mean, so this is so these are some of the great scientists that you have in Europe, and they were great writers too. Okay? So what are some of the basic characteristics of scientific writing? So one very basic thing about scientific writing is its clarity. So you have a paragraph, and if you're trying to convey something, and if it is not clear to your audience as to what you're saying, then uh, it doesn't serve its purpose. So clarity about aims and objectives is one thing. Clarity of thought and expression, thought and exposition. Then a good write up scientific write-up should do a thorough literature survey. So what do you mean by literature survey? So if you are working on a particular problem, you would look at uh, all the uh, all the scientists or engineers who have studied this problem, who have made some progress or some related developments which are interesting from the problem that you're working on. Okay, so thorough literature surveys uh, is absolutely essential for scientific writing. Then citations and referencing, I'll be talking about this in detail. And then finally, your significance and conclusions. So you've written article on a particular topic, on a particular problem, and often the question that gets asked is, what is its significance? What do you conclude from your research? And if you don't put things in perspective, then uh, then the writing is not appreciated. Okay, and often when you send a paper for publication, for instance, you may have some great content, but if you do not justify it, if you do not put it in broader perspective, then it is likely to be rejected. Okay, so the conclusions that you derive out of your research, it has to be properly written. Okay, now typically, now since this talk is about uh, research paper writing, scientific writing for research papers. So let me first tell you how a research paper is generally organized as. And I mean, this is a common knowledge, of course, but I just want to kind of quickly uh, browse through each of these points. So first you have a title of your paper, then you have abstract, introduction, preliminaries, main body of the paper, followed by conclusion, then you have acknowledgement, and then finally you put all the reference. Now, uh, you know, to to be very brief about some of these points. So, title of the paper is an important component. It should convey uh, the problem that you work towards. You worked on a specific topic and you solved a particular problem. So the title should convey that, and it should be a short and catchy title, a title that catches attention uh, of the your target audience. Okay, so it should be representative of the article. Okay, so that is an important uh, component of writing. Then you have abstract. So abstract should ideally be five lines, or maybe at most 10. So it varies again from discipline to discipline, but typically it is between 5 to 10 lines. Like in mathematics, it is often 6 to 7 sentences. So it should be brief overview of the uh, problem that you have worked on. Okay, the conclusions that you have drawn, some of the claims that you have made. So abstract should contain some of these things. And then introduction. So introduction, you have more liberty in the sense that you can put things in perspective, you can talk about history of the problem, you can do some literature survey, quote some important developments, and then uh, you can say a few words about your research, and say something about conclusions too in the introduction section. And then preliminaries are, typically these are these are the notions that may be required in order to propose the main, in order to, so you have the main body of the paper where you have quoted your main results, okay, or your research findings. But then you need maybe some equation is needed, some symbols are needed. So those preliminaries you can mention before you mention some of your main results. Okay, this is often important because if your paper is not self-contained, if some of the you're using some notations, and if the reviewer or the reader of the paper uh, is not familiar with the notations, then it can be problematic. Okay, so preliminaries, then you have the main body of the paper which contains the main results, and then followed by conclusion. So main body will of course contain the main results, and then you will be required to conclude uh, conclude draw inferences or conclusions, put things in perspective. Okay, and then finally acknowledgement. So uh, you you were helped in your research by some people or institutions or whatever. You received some funding for your research, then you need to mention this in the acknowledgement section. And then finally references. So this is how typically a research paper is organized. um, and I'm sure many of you already know this. um, Now, let me say a few words about authors and the corresponding author. So, authors are those who have contributed to the research problem. Corresponding author is one of the authors. So, there are let's say three authors in the article. They have worked towards a specific problem. Uh, then the corresponding author is one of those three authors, and he or she looks after the correspondence with the journal during the publication process. So when, for instance, the reports are reviewed, then a corresponding author looks at the reports and informs informs it to the other authors about it, and then so this is he's the one who handles the paper in some sense on behalf of all the others. Okay. And there are a few things to keep in mind. So affiliation of author should be clearly mentioned. So if you're working in a college, then your name of the college should be mentioned. The institution that institution is part of some university, let's say, then that university must also be mentioned. And this is often important for institutions also, because let's say you don't put the name of the university, then the university will not be able to showcase that as a paper. They say, for instance, for this NAC uh, affiliation, and I mean NAC accreditation and so on, or even for ranking purposes, papers are required. So if you don't mention the name of the institute or the name of the university, then your institute or the university won't get any benefit out of this publication. So it is important to mention. Of course, I mean there are authors who do not have any affiliation. If they do not have any affiliations, they need not mention it, of course. But if you have it and if you want to mention it, you should mention it very clearly. Now, some do's and don'ts. Okay, so are there any rules for good scientific writing? Okay, um, so there is no rule book as such, but there are some broad principles. So, for instance, checking your grammar. Okay, uh, so avoiding common grammatical mistakes. Now, people don't expect you uh, to be good at English. I mean, people understand when you send your paper for publication, for instance, people understand that so suppose you see, we are Indian, so it's English is not our we are not native speakers of English, right? So people don't expect you to be very good at English. That's fine. But when you write a scientific report or article, research paper, there are at least some common basic mistakes you should avoid. Okay, and you can avoid because you can ask your friend or colleague to correct mistakes, or you can use some application, some package, online package, maybe something like Grammarly you can use, to check, grammar. There are many, many other ways of improving grammar. Okay, avoid making spelling mistakes, for instance. Okay, so these are things you must do, or else uh, the reader will conclude that you are not serious about your writing, right? So this is something uh, that is a must. Okay? Then language check. So for instance, when it comes to scientific writing, your language must be formal. Okay? When you write a novel, for example, the language in the novel is different from the language in the research paper. Okay? It is supposed to be more precise, for instance, because you're writing about your findings. So you are supposed to be precise there. The language has to be formal. Okay, it is not the kind of language that you find in novels, for instance, right? And then appropriateness. So what kind of language suits your exposition, the subject matter that you are presenting? Okay, that is uh, again, something that you must observe. Then thirdly, you need to do plagiarism and similarity check. I'll discuss this point in detail. In fact, so there are packages that you can use and check for similarity index. Uh, and I'll also go into what plagiarism means and so on. Uh, so that is something I want to talk about. Then acknowledging the original authors. Okay, citing others' ideas. That's also part of good scientific writing. I mean, suppose uh, uh, you're using some result and you are not mentioning the name of the person who proposed that result. Okay, then it can very much be called a plagiarism. Okay, so you must acknowledge the original authors and their contributions. Then finally, you have choosing the right journal. So after you have written your paper, you need to find a good journal, and then uh, because the thing is, you have written an article that is interesting, then you expect that your article should uh, reach your target audience. Then how to do that? Okay, so if you get it published in the right journal, only then it is going. Uh, uh, it will reach the right audience. Okay, so otherwise it will be neglected even if it has some good content. Now let's come to the grammar part. So why is grammar important? Incorrect grammar will reduce the readability of your article. It will affect the clarity and exposition of the main ideas. Okay? And the third point is it reflects the lack of diligence and sincerity. Something I think is important because uh, like you're expected to do some basic grammar check at least. Like I said, people don't expect you to be very good at English, but so some basic mistakes have to be, like say for instance, taking care of articles a and the, right? If you don't use them properly, then that means you are not sincere about your writing. And what happens as a result of that is that it calls into question the validity of your claims, meaning that you have some good scientific content to present, you propose some very good research idea, uh, but you've not written it properly and you've made some very basic mistakes, let's say some very basic uh, mistakes in grammar, let's say, then it immediately casts doubt on your claims, because people will say that if you truly had some good content, then why didn't you do this, basic things like grammar check, for instance? Okay, so this calls into question the validity of your claims, the claims made in your research findings. So therefore it is important to do some grammar check. And there are packages which allow you to do this. So Grammarly is one package, for example, and it can be purchased. So in the purchased version, you will have uh, many features. But in the free version, I think you won't have that many features. But it is good to use. So I've used it in many of my articles. Uh, and often when you write about your research, uh, you often, there are you are human beings, so you make mistakes, right? You're not good at English, for example. So then such mistakes are bound to happen. So what do? You use such packages. So careful of usage of articles A and the is important. Okay, and particularly when papers go to the reviewers. So like recently, I received a referee report saying that the article is very good. We have some novel ideas, but then like reviewer has given me some 10 to 15 uh, told me some 10 to 15 places where I have not followed A and the where I have not used A and the properly. Okay, so uh, using packages can help you avoid some of these mistakes. Okay, and so one way is to use Grammarly, for instance. The other way to do that uh, is to read research articles, good research articles, scholarly research articles, and you observe the kind of language that these articles use. Okay, and then you get a sense of how in your subject area, for instance, how good writers, good scientists, or good engineers, how they write. Uh, because you need an understanding as to what is the benchmark. Okay, so have the habit of reading good scholarly research articles. Then you can consult your friends. You're not good at English. You consult your friends, colleagues. You will have someone around you who's good at English. So you consult them and get your grammar right. So these are some of the things you can do to improve your grammar. But note that grammar alone does not make for good writing. Okay, so a sentence may be grammatically correct, but it may not be appropriate for the for the topic that you are writing about. Okay, so and so each discipline will have its uh, its what you call uh, its style of writing. So mathematics will have some style of writing, uh, whereas mechanical engineers, they will have some style of writing. The level of formality, rigor that is expected of a mathematician or a mathematics person is different from the level of rigor and the kind of language that is to be followed. So for an engineer or for a mechanical engineer or even for a computer scientist. So there are these minute differences, of course. Uh, but the main point is that just grammar being correct does not mean good writing. Okay, you need much more. Grammar is of course important, but beyond grammar, uh, there are many other aspects of scientific writing. So formal writing style, for example, I mentioned this a while ago. So in mathematics, for example, uh, you have to have a very formal writing style, and I think that is also true in other sciences, but not so much in other sciences. In mathematics, this is often there's a high kind of degree of formality that people expect you to be in. And that the reason is maybe because the nature of the subject. In physics, you can make some casual comments, right? Like you make some assumption about some data being normally distributed. That's kind of you allowed in physics or in other sciences, biological sciences, for instance. You make some assumptions without justifying why that assumption is made. Okay, but in mathematics, people are very careful. Okay, people are in some sense not so tolerant, and they expect you to justify each and everything, and that's part of formal writing style. Now, even if you're expected to write very formally in any in a, be it in any discipline, but then even then you have to use a language that is inclusive and easy to understand. Your ideas may be complicated to present, but then that is where you need a language that should be understood by uh, as much as possible understood by even masters or even undergraduate students. Okay, so easy to understand language is also important, and to do this, one basic principle is using shorter sentences. One idea, one sentence. Often what happens is, you have some idea which is a little complex, and then you try to crunch everything into one sentence, and then it can be confusing for your reader. So a general principle that is often that often people follow is one idea, one sentence. Broadly, there are sentences where you would need more. I mean, you so in one sentence you may have two ideas in some cases, but broadly you should have one idea, one sentence. Okay, is something you should follow. Okay, then let me come to this plagiarism part, and I'll explain some basics of plagiarism, and then I want to give you a small demo. Maybe we'll have a small 5 minutes break a little later, uh, and then have this demo on Turnitin. There is a package known by the name Turnitin, and it's a tool which you can use to check plagiarism. But let us first understand what is plagiarism. So plagiarism is presenting ideas or work of others as your own. That is without acknowledging the original authors. Presenting it as your own. So someone else has done it, but you're presenting it as your own. So that is plagiarism broadly. Okay. Um, and you must have heard this term research ethics. Okay, so plagiarism, research ethics means ethics that you need to follow while doing your research or carrying out yeah, or presenting your research, publishing it, and so on. So there are some ethics that you have to follow. These are called research ethics. Okay? And plagiarism is violation of research ethics. So your institute, for example, so one of the consequences that often people face when they are found to be involved in plagiarism is that their institute. So, for instance, I am working at Pune University, and yeah, if suppose tomorrow I'm found, if I found uh, copying someone's work and making a paper out of it and publishing it somewhere, then that's called plagiarism. And if suppose my university uh, takes a note of this, okay, then I may be punished by my university for violations, for violating these basic norms, because if you're involved in plagiarism, that will bring um, bad name to your institute naturally, and there are of course other consequences. So that is a violation of research ethics, and you can get punished for this. You must remember this. So punishing is different thing. I mean, getting punished for doing this is a different thing, and if you're really sincere about your research, it is clear that you won't do such things. I mean, you want some respect. I mean, as a researcher, as a person who's honest and has some dignity, you wouldn't want to get involved in such things, right? So that is more important. But even if that is so, even if you don't want to copy someone else's work and present it as your own, even if that is so, um, unintentionally you may be doing it. Like when I was a PhD student, um, in when I was in the first year or so, and we were asked to uh, present. In the first year, at the end of the first year, we were asked to uh, make a report of the problems that you want to work on and present the report to the department. And so I did it, and I quoted many results, without mentioning the original authors. I didn't know about it, that you have to mention if you're quoting a particular, let's say, theorem or an equation or a formula, then uh, you have to attribute it to some author. Okay, the original author must be mentioned. Okay, so this is a common practice, but being a first year student, I didn't know about it. So unintentionally, I presented this report without caring about acknowledging the original contributors. And then my advisor scolded me. He gave me a warning that so the of course when he taught me what it means to cite, give citations to others, duly acknowledge others. And then this basic principle that if you're quoting some result, then it must be attributed to some author. If you don't attribute it, it is understood that it is your own. Okay, so many times, what I'm saying is basically, you may not uh, uh, you're not really plagiarism, involved in plagiarism, but yeah, unintentionally you are doing it. So such things also have to be avoided. Okay. And then question is, are there any applications or tools which help you to avoid uh, plagiarism? Okay, so one such package that we use at our institute is Turnitin, and it gives you what is called similarity index. So, so there is a subtle difference between similarity index and plagiarism. Okay, and so what is similarity index? Similarity index is, so when you use some package like Turnitin, for example, what it does is it gives you similarity index. And in the similarity index generally means that if you have your paper, so how similar uh, the content is. So suppose there is some paper that has already been published, let's say XYZ paper, and in that XYZ paper, some of the things that you have mentioned in your paper are in common intersection. Then uh, there is a similarity. Okay, it doesn't mean plagiarism. Okay, there is a similarity. So maybe you have quoted a result from a particular paper, say XYZ paper, and so therefore it will naturally show some similarity, but you have attributed that to the original author, the XYZ paper, whoever the authors are. You have duly acknowledged them in the paper by citing them. Okay, then that is not called plagiarism. Okay, your package, let's say Turnitin, it will show some similarity with the other papers, but you have acknowledged them, you have cited them, so it will only be a similarity index and not a plagiarism. Okay, so one needs to get into the question of what is plagiarism, and how it is different from uh, similarity index. Okay, and so one way to one way to avoid plagiarism is to use these tools such as Turnitin, because unknowingly maybe you have proved some formula, but that's already there in the literature you don't know about. Then plagiarism check will take care of this. So by using plagiarism check, you might come to know of an article where some such thing has already been done, okay, or has already been discussed maybe. So that's one way to avoid uh, plagiarism. And another sort of way is to understand how eminent scientists or say engineers, how they cite other people's ideas or works. That is again something that you must observe. Now, maybe at this point, I'd I'd like to take a 5 minutes break and then uh, continue this presentation, where I want to basically uh, give you a small demo of how Turnitin is used to get the similarity index. So let's break for 5 minutes. Okay, let us begin. I hope I'm audible again and my presentation is visible.
Yes, sir.
Okay. So just a minute, huh? So I hope you can see this Grammarly. So I'll go to Turnitin, but before that, I hope you can see this window. Grammarly, I've opened my Grammarly account. It's so we actually have this institutional account, but the version that I'm using on this PC is the free version. There is a license version which unfortunately I do not have it here. I mean I have some login credentials, but I have to see. But anyway, so basically this Grammarly package will allow you to check grammar. So for instance, I have this my LaTeX file. So again, LaTeX is a great scientific writing tool, particularly if your work is very mathematically driven, you have lots of equations, uh, then this is a very good writing tool. So I have this LaTeX code here, say abstract. Then I simply put it, where is it? Grammarly. So I paste it here, and then I have these various filters. Yeah, so this is my LaTeX code. I mean LaTeX, the thing that I've written in LaTeX. This is my abstract, and once I put it here, then it tells me various places where I need to correct the grammar. So for instance, it is giving, so you will see this red highlighted part. So be the zero divisor graph associated to, and then it is suggesting me that you replace it this two with width. And then when I click on this accept button, then this two becomes width. Okay. Then remove the space. So this next suggestion is remove the space. So we associate. So there is maybe more space, but the thing is that this is a LaTeX code. I mean, I'm doing it in LaTeX, and so space is not an not never an issue, because it automatically kind of the ideal sort of space it takes, so you don't have to bother about this. Okay, similarly the second suggestion is remove the space, remove the preposition. So the third one is remove the preposition. So off, p and off minus q. So it says you remove this off, and if I click on this, then off is gone, p and q. And these are so this is the third one is again remove space, which I don't bother about since I'm working on LaTeX. And the last one is add a comma. So rank and nullity. So this is the one where it is giving me a suggestion, this and. So and, so rank comma. So before this and you need a comma. And so by the way, this comma and full stops, they are important, have to be observed. And many times, it is when we write things, we don't worry about these things, and as a result, I mean it uh, decreases the readability of the article. Or some statements can be confusing if you don't put a comma or a double colon or whatever it is. So here, for instance, it is asking me to put comma after rank, and I accept it, and then it is done. So this is a small example where you can correct your grammar. It's a great writing tool, uh, and the free version is of course available, but then there are paid ones which have more features, I believe. Okay. And then you know, once you're done doing this, then you simply copy this code and put it back into your LaTeX file. Okay, so let me do that here. So I copy it, I put it here, and then I compose my LaTeX file, and then it gives me this output. Okay, so LaTeX is another writing tool you can use. So I'm not here. My purpose here is not to present you with the deep, this LaTeX package. Okay, let me go to Turnitin. Turnitin. Okay, so let me use my official credentials. Okay. So I think there are some, I don't know if there is a free version here of this Turnitin, but there are free packages also. Like I think Urkund is one such. You can try this. I've never tried, but you can try this. So this is my, so I don't want to say this is not a session on Turnitin as such, but I just want to show you how it gives you, how it calculates this similarity index. Okay, I just want to give a small demonstration. So, so I can, if I want to create I want to submit a file and then ask it to calculate, uh, I ask it to do a plagiarism check. Then I need to create this add class. So add class standard, let us say research writing. Enrollment key will be, let's say, like this, subject mathematics, student level, let's say postgraduate, class start date is 18 Jan. So this is typically for class where you can ask your students to submit and then do a black check of it. I'm creating a class. So it has been created. Now in here I can add an assignment. So add an assignment. So assignment title, let's say research project. It's the title of my assignment. No report. So then there are these filters which have to be set. So allow only file types that Turnitin can check for similarity, or allow any file type. If you allow file type, then it will check similarity with all kinds of files. Then submit papers to standard paper repository and no repository. So I suggest that if you are writing a paper and you have not communicated to any journal, you have not put it on archive, for example, then you set this to no repository, because once it gets into repository, it can then it can show a self. Then that is also one of the papers for it. I mean, if you do the plat check again, then it might show some similarity with the same paper. So you better set it to no repository. And then there are some optional settings, like enter some special instructions. So if this is for students usually. Then allow submissions after due date. This is usually for students. If you're allowing some submissions, similarity report, generate similarity reports for submissions. So this is set to yes here. Generate similarity reports for student submission. Okay, so this also is not important for us. Exclude, so this is important for us. Exclude bibliographic materials from similarity index for all papers in this assignment. So if you are doing a plat check, then do you want to include or exclude bibliographies? So so this is asking you to exclude bibliography, and you usually you would like to exclude bibliography. But if you want to include it, you can do it. Exclude quoted materials from similarity index for all papers in this assignment. So yes, exclude small sources. So for instance, if you say no, then you will be excluding the small sources, meaning that, so suppose you want to say yes, exclude small sources. So yes, then you will have to provide the word count. So for, if there are four consecutive words, then it will, that is your threshold. So above 4 words only it will show some similarity, else it will not. Okay, so this is what it means. This is about students. All fine with the basic filter sort of. So submit. So you will figure out, I mean, my purpose is not to teach you, um, new this specific package. You will figure out once you log in, you have your credentials. You can figure out. My main purpose is to show you how the report, what kind of report is generated. So now I want to submit something. So I'll have to add student. And then go to assignment again. So add the student, submission title, my work, let's say, and then I use some paper. So this is my actually published paper. So let me use it. Okay, and then it will process it. Since it is published, it will most probably give me a lot of similarity. Okay, and it takes some time for the report to be. This is where the report is generated. Okay, it might take some time for it to. So it has generated. It is showing 75% similarity. So let us check. Where is this? What is the 75% similarity? Now the reason, so see why you have this level of similarity is because this paper is already published, and I have my PDF file and I've submitted it to. I mean, I have this. I'm getting black check done from the Turnitin. So naturally, it will So look at this. Look at this. So it is telling me what is the common content. Okay. So you see this paper. This is the same paper actually. It has appeared in this AKC International Journal of Graphs and Combinatorics. So this same paper, it is showing that it has a similarity with this paper, and the similarity 72%. Okay, it is oddly, I mean, it is not saying that it should be 100% actually, but maybe this is not the revised version, I think. So probably that is why it is showing 72%. And then other sources. So for example, this discovery.researcher.live, there is 1% of similarity. There's another publication of mine where it has a similarity of less than 1%. So typically people accept, I think, below 4%. Some people accept below 2% of similarity. But similarity does not mean plagiarism. Okay, so this has to be understood clearly, and that is because you may have acknowledged the original authors. So similarity, there is bound to be some similarity with other papers, but similarity doesn't mean plagiarism. So that is something you do. So it is giving us all the articles and their references So for instance, this link, for example, is giving us all the articles where you have some similarity. Okay. I think the full one is not. Yeah. Maybe I think I should have submitted some article which is new, because then it shows so many colors. Okay, maybe I think let me go to. Yeah, maybe this class, let me go to and see if I have this. Yeah, this 22%. So this was my old file. So here there is a 22% of similarity, and now you see, you begin to see various colors. So this orange part is quoted from some other paper. This red part is from some other. But note that, so let R be a commutative ring with unity frame. So let R be a common. So this is going to be a very common sentence in mathematics, but it is coming under similarity. Okay, so one has to use these packages very carefully. Okay, so this interplay between graph theoretic and properties of the associated. So it is showing that it is common to some articles, some set of articles. So there's bound to be some similarity. Okay. So actually, the thing I wanted to show you, this old report. Yeah. So this is old report. I'm showing you some old report where it has highlighted with various colors. So 12, 3, 9. And on the right hand side, it will tell you where it is, where these things have come from. Okay. And then at the end of it, yeah, so this is the one I wanted. So it is showing that there is a 20%, 22% of similarity index. 15% is from internet sources, 19% is from publications, 2% from student papers and so on. So this classification is given here, and then it is paper-wise similarity is given. So one of our papers, for example, this AKC International Journal of Graphs and Combinatorics is showing that this particular paper has 3% of similarity. Then there is some archive paper with which this has 2% similarity. Then there's another paper with this paper, it has some 2% similarity, and so on and so forth. And then there are these 1% similarities, and then there are papers which are less than 1% similar. So it is giving you full description, and then you can maybe, if you are say for instance here there is a 2% of similarity and you want to see where what this paper is, you can immediately go to this paper and check. And this purple part, you will be able to see it here in the, there are these various colors. This purple part is this purple, or maybe the third, I mean, what is the index here? 3. So the 3 you locate. So this 3 is here. The graph GR is then a graph with vertex at P. So such things have been, it is saying that such things are there in that paper, the third paper by Anderson and so other authors. Okay, so you can then, if you want to minimize this similarity, sometimes there are some technical requirements that you have to have less than 2% of similarity. For instance, we submitted a paper to some journal, and then it said that you have your similarity indexes, whatever, some 3% or 4%, and then you need to reduce it, bring it down. And so we did a black check, and we found that then there are some, some usual sentences like let G be a graph with vertex at V, and then you have, it will show you, it will tell you that it has similarity with so and so paper, and then you can go to that paper, or maybe that particular part you can modify a little bit. If the technical, see, ideally it shouldn't be a problem. I mean, but then it's a software check, so you can't really argue. I mean, with the journal, you can't really argue. So what you can do is you can simply reword some of the sentences, and so that the technical requirement of bringing it down to, say 2% or maybe 1% is possible sometimes. Okay. Or even if you are submitting a PhD thesis, so there are some technical requirements. So in our university also we have to fulfill these requirements, that your black check, your similarity index has to be below this, below that. If it is above that, then you will have a committee, and the committee will look into whether there is a plagiarism happening. And if the committee says, okay, there's no plagiarism, then it is cleared. Okay, but then there are some requirements, and this, in order to fulfill these requirements, you may have to look at these more carefully and closely. Okay, so I hope, so yeah, so maybe let me see the report. Oops, where is it? I don't know where it is. No, this is older one. I wanted. Oops. Yeah, research writing. This is the one. Yeah, so this is the thing. Okay. So it gives you a detailed report which you can download and see for yourself. There are various options you will figure out. I mean, like I said, my aim is not to teach you how to use it, but instead just to make you aware of some of the issues involved. Okay, so this is about this package. Now let me go to the next point. So using software tools is one way to avoid it, but it's not the only way. Okay, so because these applications will have some limitations, so so you have to be mindful about these limitations. Now, another important point is acknowledging others. So many times when you carry out your research, you are helped in your research by your friends, peers, or even academic institutions. A particular instrumentation facility is not available at your institution, so it is available maybe in some industry or in some other academic institution, and they provide their facility to carry out the research. Then you should acknowledge. Not acknowledging it is not good, not ethical, so to say, and so you must acknowledge it. Okay, and so for instance, you may have received some funding from some agency, then you need to acknowledge this in your report or in your paper. Okay, funding agency, like I mentioned, it is important to acknowledge, because see, many times, so for instance, if you are working on a DST project or some government funded projects, then they see to it that you acknowledge them in your research papers, for instance, or in the reports that you write. They see to it that you acknowledge, because when you at the end of your project, they ask you to present the output of your project, and they ask you to submit your papers. Then they check whether or not you have acknowledged them by citing the project number, project file number, okay, and or if you have used some equipment or service, you procured some equipment by using the funds allocated by a particular funding agency, then it has to be mentioned. So for instance, in one of my papers, so I was working on a project funded by DST SERP, Science and Engineering Board. And so you can see that this funding part has been mentioned here. The author thanks DST SERP for financial assistance under the project. This project number is mentioned, Department of Science and Technology, SERP, right? So this is mentioned here. So funding part has to be very clearly mentioned, because then at the end of the project, they ask me to send a screenshot or the particular page where I have acknowledged them. They ask me to do this. Okay. Then acknowledgement. So here in the acknowledgement section, I've acknowledged, for instance, I've acknowledged the referee. So we thank the referee for many pertinent comments, in particular for pointing out the simpler proof of the lemma 2.2. Example 2.3 is also due to referee. So referee has made some very good comments, so some important comments. So he simplified some part of the proof. So we thanked the referee. Okay, and then we also here in the paper I've also thanked one of my colleagues, Vinayak Joshi, for many useful discussions, because often when you're working on your problem, you tend to discuss with your friends, your colleagues, or experts in the field. You write an email, they give you some guidelines. Okay, you work on this kind of you work on this paper, they give you some pointers. Okay, so that has to be also acknowledged, because they have let's say they have provided you some key insights. They have not directly helped you in carrying out research, but they have provided you some guidelines which are helpful, and you don't mention their names, then it doesn't look good. Okay, so this has to be done properly. And one way to learn this is to observe how eminent people, some scholarly articles, for example, you read these scholarly articles and see how these in these articles you find acknowledgements. Some casual discussions are oftentimes cited. I mean, they are mentioned that with discussion with this person has helped us gain an insight into so this is often mentioned by people. So that's acknowledgement part. And yeah, so ORCID ID or ORCID ID, ORCID, okay, Open Researcher and Contributor ID. So this is again one thing I want to mention. So for instance, you can see that my ORCID ID is here and it's been quoted here by the journal. This is because what is ORCID? Open Researcher and Contributor ID. So this ID is given by this corporation, ORCID corporation. You have to apply online, of course. It's a small 5-minute process, and you have to give them, supply them your details of your institution and so on, and then they give you some unique ID. And what does this unique ID do? It addresses the problem of multiple names. So so by Ganesh Kadu, you will have several people by the name Ganesh Kadu. It's a common name, say, let's say. Then there's a problem with attribution. So if you search by this name, then it is not clear which Ganesh Kadu it is. There is a paper by name. It is not clear to you whether or not it is me or some other Ganesh Kadu, right? So to avoid this problem, you have this concept of ORCID, this unique ID, and this is how it looks like. So this is my ORCID ID. And the other issues are, for example, why you need to use ORCID IDs, because there are change of names. So particularly with women, this is a problem after marriage. You have change of names, and then it is not clear um, uh, what it is not clear which person it is. So identify the person with the person's research. Okay. So that is one of the issues. Then inconsistent use of abbreviations. So sometimes in some papers I write Ganesh S. Kadu, in some other papers I write GS Kadu. So it is not clear to the reader whether Ganesh S. Kadu and GS Kadu are the same or different. Then there are cultural differences in writing names or name orders, and that also creates problems. So to avoid this, you can create this ORCID ID and quote it in your paper. Okay? So for example, let me go to this ORCID page. So this is ORCID page. Here I type Ganesh Kadu, and you can see that there are two names. Okay, two people by the same name, Ganesh Kadu. And so I click on this one. So this is my page, and it is giving you various articles by my name. Then DOIs are digital identification numbers are also given. The other authors are also given. The title of the journals and papers, they are all given here. So you can use this too. So for instance, you want to see if you particular what you have some specific person in mind and you want to know, or there are two people by the same name and you want to see uh, their contributions, then you can go to their ORCID pages and observe and uh, see the attributions here. So it's a good thing to have this ORCID ID and use it for communication purposes. Okay. Choosing the right journal. Now this also is a crucial part. So this actually requires fuller discussion, but let me say it briefly. So if you want to choose, so you've written your paper, you're done with grammar check, language check, whatever. Okay? You've organized your paper, you've consulted your friends, okay? And you've come out with a good article, and now you want to send it to a journal. So you would obviously like to send it to a good journal. So how do you, what does it, I mean, how do you select a good journal? What is the meaning of a good journal? Okay. So what are the things you, how do you decide? Okay, how do you decide if a particular journal is good or bad or average? Okay. So first thing I think you should do is look at some of the previous papers published in that journal and see, go through their abstract introduction, the kind of problem that is solved or discussed in this paper. So, okay, so by observing previous published papers, by assessing the quality of papers published in previous issues of this journal, you can gain some understanding about the journal, and this is a very good way to judge the quality of the journal. Then the second thing you should do, so this is the first point that I've written here, right? Maybe I should have written this first. Anyway, so editorial board is another thing you should look at. Okay, so let's say there are 10 editorial, the editorial board consists of 10 members. So you look at their profiles, um, what kind of researcher they are. If they are eminent people, then the journal is likely to be a good journal, right? Because editorial board is what controls the quality of the journal, the kind of papers that are accepted in the journal, or the kind of papers that are sent for review. Or the there are some papers that you do where you send, where the editor sends it back to the uh, researcher. So this decision is often taken by one or two editors, and so it is important. So good journal will always have a good editorial board. So this is the one. This is thing that you me to observe. Okay. Now, I share you with an experience of mine. So from 4 years ago, I was looking at some journals, and there was one journal, I think, goes by the name of some International Journal of Algebra, some general title like that, some journal in algebra, some International Journal of Algebra. And I looked at its editorial board, and so there were about 10 members, and most of them were eminent mathematicians. But then there were two members about whom I was suspicious. So I looked at their profiles, and to me, they seem to have some dubious credential, dubious, I mean, track record. Their publications were not good, but they were there on the editorial board. So what typically happens, used to happen was, so I also looked at the quality of papers, and I was very sure that it's not a good journal. So why this happened in spite of 8 members of the editorial board being good? So the reason is that if you want to, if you have some paper, some very trivial kind of paper, doesn't have any great idea or anything like that. So if you have some such content, maybe plagiarized content, okay, and you want to send it to some journal. Now, good journals will not accept this because they have their uh, editorial board and various standard practices. But this particular board, 8 members of them were good and two were not. Uh, two had some dubious, suspicious, uh, problematic kind of track record. So if you are clever, okay, what you would do is you would send it to these two people, and they would most likely accept your whatever you have, they would accept it. So these 8 people are there just, I mean, they're not doing anything. Their names are being used. Okay, so such things have to be observed. Then the other thing you can find out about the journal is opinion of peers about the journal. So experts in that area, how do they value that particular journal? That also needs to be observed. Then there are these indicators or metrics like impact factor, IF or SNIP, which is called the source normalized impact per paper, or SGR, which is nowadays being used, Scimago journal rank of the journal. So these indicators will give you some idea about the quality of the journal. Okay, so impact factor, how is impact factor calculated? Uh, so typically they look at uh, papers published in last 2 years, and how many citations have they received in this year, for let's say, and divide that by the number of papers published, and then that gives you the, if the papers in that particular journal have received high number of citations, then the impact factor will obviously be high. And if it doesn't have that many citations, then the impact factor will be low. Okay, and then SNIP is the source normalized impact per paper, where this is typically the impact factor divided by the database citation potential. Because what happens is, for instance, in mathematics you don't generally receive that many citations. Okay, so as a result of that, mathematics journals will often have low impact factor. So how then you can't really compare a journal in mathematics with a journal in biology, say something like Science or Cell or Nature. It's difficult. You can't really compare. I mean, the yeah, sort of, let's say, Annals of Mathematics is a very high standard journal, but it doesn't receive that many citations. So impact factor is not a good indicator. Okay, it can miss a lot of things. Okay, so for instance, in a journal like, say, Annals of Mathematics, uh, where some very deep articles are published. So what happens is that it can take many years for people to understand these articles. and as a result of that, in the short term, uh, these articles may not get cited in other journals, and but in the long run, people will take a note of these articles, and they would get cited. So if you look at some, let's say, previous 3 years or previous 2 years citations, then such journals will be left out. They will have low impact factor. So therefore, the impact factor is problematic. And then source normalized impact factor in some sense takes care of this. So it doesn't really take care of this also, but it's a slightly different version of impact factor, where you divide by the discipline specific factor. And then in SGR, SGR is the SciMago journal rank, where what you do is uh, you also look at who's citing. Suppose you have a particular journal, let's say XYZ journal, and the papers, so let's say it has a particular paper, or the issues, all the papers in that journal have received, let's say, 100 citations. But which journals have cited these? What are these 100 citations? Where have these 100 citations come from? Have these come from good journals? If they have come from good journals, then the journal rank will go up. If the citations are from some not so good journals, then they won't count much. So this SGR takes into account uh, the it assigns the weights to the citations. So this is similar to Google page ranking, where there are some web pages which are uh, which are cited by, or which are linked to by, pointed out to by, pages of uh, high rank or important pages. Then the rank of the page in question goes up. So this is similar to Google page ranking. So these are also some indicators you can look at, but then you will have to look at their definitions, so that you get an idea as to what it really measures. You don't just go by the impact factor. It can be misleading. Just looking at the impact factor alone, or looking at the SDR alone, can be misleading. Then the other thing is quarters of journals, quarter one, quarter two. So first 25% of journals in a particular area will be termed as quarter one, quarter two. So there are agencies which do this. And so being able to read these scientific metrics, such as impact factor or SNIP or quarters of journals, is crucial to choosing the right journal. Uh, and let me bring it. So this is the SCI, the SciMago journal ranking website, where you can take a look at uh, the journal rankings. There are also country rankings, but let us look at journal rankings. And then you can select, let's say you select computer science. In computer science, you have, let's say, artificial intelligence, and then it will tell you the different journals, so foundations and trends in machine learning. This is a quarter one journal, and its SGR is 13.775, and there are the other metrics are given here. Okay, so for example, H index, total documents, these are in 2022. So if you scroll your mouse over uh, these points, then you will see what it indicates. So for example, cites per doc. So average citation per document in a 2-year period. This metric is widely used as impact index or impact factor. Okay, and then the countries are also mentioned here. So these are some of the indicators that you can check. And so quarter is, in my opinion, a better measure, SGR or quarter. So quarter one journals are likely to be good journals, but don't just go alone by quarter. You will actually have to go to the website, check the kind of papers that are published, the editorial board. So there is some subjectivity involved, but these journals are likely to be good. So this IEEE transaction, for example, is considered to be a good journal, I believe. Okay, Journal of ACM. Okay. So these are all quarter one. So after quarter one, you will see some quarter two journals. So here, these are all quarter one. Yeah. So here from this Journal of Parallel and Distributed Computing. Okay, so this is a quarter 2 journal, so almost on the border. Okay, so maybe if you check it after a year or so, it may be in quarter 1. Okay, applied intelligence is in quarter 2. So you should know how to read these databases. Another database that is important is this Web of Science by Clarivate, where you can search about a particular journal, let's say Journal of Algebra. Okay, this is a Web of Science, and then it tells you various details, the publisher, the ISSN, whether it is part of this Web of Science core collection. So it is a Science Citation Index Expanded, SCI journal, so-called SCI journal, Science Citation Index. Okay. And then you can also check its profile page, uh, where it tells you, where it gives you the website and that what kind of journal. So what is the frequency? So it's semi-monthly, the country, right? Issues per year. First, when was the first issue published? So it was in 1964. It means that it is an old journal. So old journals are likely to be. I mean, usually they have over the period of time they have developed some. I mean, the old journals are likely generally are good. Not all of them, of course. Okay, and then you will see various indicators like journal citation indicator. Okay? And the meaning of these indicators is also given here. So in 2022, for example, it was 0.79, and then 2021 it was 0.82. Okay, and the other peer review information. So type of peer review, that it is single blind. That means the reviewer knows who you are, but you don't know who the reviewer is. So there is no chance of you influencing reviewer in any way. Okay. So these are some of the things you can find out. Okay, so yeah. So like I just want to kind of end with the question. So if a journal has a high impact factor, does it always correspond to being held as prestigious or good journal? And like I've already told you, it is not necessarily true. Why that is so is because there are many reasons why high impact factor journal may not be the right choice. So high impact factor does not always mean good. Okay, that is something I think you should keep in mind. There are other indicators you have to look at, and after you have seen or read all the indicators, you also need to do some subjective analysis. You actually need to go to the journal website and look at some issues, look at some papers that are published, and then look at the editorial board, for instance, I was telling you, and then you will get a better sense of what the journal consists of. Okay, so to close this session, this is my last slide. It is important in research to be honest and sincere, to have ethical approach, to remain curious, because in research it is important to be curious. If you are not curious, you cannot really carry out any meaningful research. And these qualities you develop over time by observing others, and they will automatically, if you develop these attributes, this will automatically get reflected in your writing. Okay, so it is not it's not a question of you can't you are not sincere about your approach and you still write a good article. That is not possible. Okay, if you develop these qualities, and then automatically these will get reflected in your writing. Okay, so I'd like to close my session here. I hope you found this session useful. not sure. I'm like I already told you in the beginning that I'm from the mathematics background. So of course, I mean mathematics is used in other branches, in all the branches, including biology and chemistry, physics, and all the engineering sciences. Computer sciences, for instance, is heavily mathematics-driven branch, and which I have some knowledge about. Uh, but there are a lot of differences, I think, between, say, for instance, mechanical. There are a lot of commonalities, of course, but there are a lot of differences also. But nevertheless, I hope I have communicated to you some general basic principles of scientific writing, and like I to summarize, I mean, one advice that I would like to give you is to read scholarly articles by eminent people, uh, because uh, one exemplarity, I think, has a lot of value. Okay, so model examples. There are some model examples, be it in any field, computer science or mathematics or any other. There are some model examples, and there are people who write well. There are people who do some genuine research, outstanding research. So one must follow them. Okay, one must look at how they write in particular and follow them. So yeah, so thank you very much. Are there any questions?
Yes, sir. There are some questions. A participant Raj Kamal is there.
Mhm.
Uh,
Yes, Raj.
Raj Kamal, sir, you can ask question now. Even Rashmi ma'am. Solwat sir and Sunil Yadav sir. Anyone can ask the question. Otherwise, you can put your questions in the chat box.
Yeah, you can
So,
put your question in the chat box, or you can
unmute your mic and you can ask the
your
questions
mic
as
and
well.
ask the question.
So anyone from the participants who has raised their hand, they can ask the questions.
It looks like
Yes, sir.
fine.
It looks like.
So if you have any general questions or anything to ask me, you can email me. My email ID is ganeshkadu@gmail.com. Maybe I'll just type in here.
So one more question from Nishigandha ma'am.
Yes.
Can you able to see in the chat box, sir?
Wait a minute. Yeah, any other app or link to check plagiarism? Yeah, there is Urkund. Like I said, this is a free sort of software. I've never used it for lag check. Okay, I've typed it in here. Urkund. Urkund is another package you can use. So Turnitin, I don't know. You can check if it is freely available. I mean, at least some free version should be available. I don't know if that is the case, but Urkund, I think, is available, so you can use it.
Yes. Anyone again? You can ask the questions. A feedback link will be shared after this question answering session. So I requested participant to please wait for a minute. I hope there is no questions from the participants, sir.
Yeah, okay.
We should conclude. So thank you, sir. It was really nice session. You have